Welcome to the ET420 how-to video on the MPLABX startup. Here I'm showing the connections for our LabX demo board. It's shown here in the middle, and we're going to need a power supply for this, and it is going to plug into the wall, and it's going to plug in here, and this is about 9 volts DC. We also have our ICD3. This is our programming puck, and it needs to be connected to the computer with a USB cable, and then it has a small phone cable which is going to tie into the connector there. And that's pretty much it for the connections. Here I'm showing the details of our LabX demo board. Again, we have our power cable and we have our ICD3 cable. And here's our 10 segment LED, and this first LED is going to be the on LED, and we're going to utilize the far right 8 LEDs. This other one would be another on LED if we change the polarity of our LEDs by flipping this segment. Here's our matrix keypad. And here's our 16F8877 microcontroller. And if you look closely, it is mounted upside down. That's on purpose. All these ICs are upside down, and I don't know, that's probably the designer didn't want people to copy it, so everything is upside down. This is a connector here for our IC, and we can flip this switch up to remove it and flip it down to lock it into place. Here we have 3 potentiometers and our reset button, and that's pretty much it to get us started anyway. First thing we need to do is go into Canvas and upload our folder with our programs in it, and then we can open up our MPLABX IDE, and we could go from there. Well, here's our MPLABX IDE, and first thing we need to do is we're going to go to File and make New Project, and we're going to use Microchip Embedded, Standalone Project, Next, and we're going to go to Mid-Range 8-bit MCUs, and we're going to go down our list to a PIC 16F877. And once we have that, we're going to go to Next, and we are going to choose the ICD3. If it's been selected before, it'll have a serial number, but right now it's new, so it won't have it. Just go ahead and choose the ICD3, and we need to check the XC8, and we should stick with the version 2, and then go Next. And let's go ahead and grab a folder. Let's go ahead and use the folder that we chose. So it's on the desktop, and I am going to use PIC LabX, sorry. And let's go ahead and we're going to call this first name, I think we're called it LabX Demo 1. Okay, and finish. So when we go to projects, it should go up. And what we're going to do first thing is we're going to go to source file. So this program has one source file, only one. So we're going to go to add existing item, and we are going to go to our desktop again and go into our folder, pick LabX Demo, and we're going to pick the first file, LabX Demo 1. And if we double click on it, it should come up with our file. And we could close the output here, and everything's right here. Okay, let me go through the program here, but first thing let's do is let me show you here how to make it a little larger. So I'm going to go to fonts and colors. So it was tools, options, fonts and colors, and I'm going to make this 18 to make it easier for you to see, but we have control over just about everything here. So if you need to make it larger, go for it. And good. So let me go through the program here. So this is a comment. So we have a block comment with a slash and a star and a star and a slash. This would be a text only for comments. Okay, double slashes would be also comments, but only one line. Here we have our configuration. So these are configuration text that turns on and off certain things. So here we have the oscillator. It's going to be a crystal, watchdog timer, power, enable, all these things, and I'm going to set them for you. Here I'm just defining the crystal frequency of 4 megahertz, and that's going to be for delay. This include is going to go out and look for this is our programming language, XC, and these are 2 more headers that we may use in the future. Here's our main program for C, and it's an integer based, and these are our braces. So always these have to be braced in for C, and we have another set of braces here. And so that's necessary that they match up. And here we're setting our analog to digital converters to just straight digital. Here's a tri-state. We're setting that direction as out. And this is clearing port D, which our LEDs are on. While 1 is going to repeat this continuously between these. And as you see, we could click on it and turn them yellow so we know that it'll have a match pair, so we could go through and trace that. It's convenient. So here what we have is port D is off, and we're going to go ahead and let's make that FF, and that should turn our LEDs on. So let's go ahead, and we could go ahead and compile it. This is clean and build, and it'll go through. And build successful is good. After I compiled our program here, I noticed that we have some error icons here. I went back and checked on this. This is okay. This is an older microcontroller that was built before the software version, and it's going to error out because it doesn't meet the new standards, which the old processor can handle. So anyway, so let's go ahead and program, and we're going to go up to this arrow here, and it's going to make and build at the same time. ICD3 is our programmer, and it's going to ask us that it's a 5-volt device and not a 3-volt device. Okay. And when you see the green on the bottom, that means it was successfully programmed. Programming verified complete. Good. Here's our output of our LEDs, and we show all 8 LEDs, and this one is going to be D0, and this one over here is going to be D7. And this one over here is our power LED, and it looks good.